Hello students! Welcome to our third week of online class. In today's video, we are going to study about ordering fraction and finding the lowest common multiple. Are you ready to watch and listen to our discussion? But before that, let us read our words to learn. Number 1, greatest. Again, greatest. Number 2, lowest. Again, lowest. Number 3, ordering. Again, ordering. Number 4, comparing. Again, comparing. Number 5, finding. Again, finding. Very good. Now, in this video, you will watch the 2 topic. Please watch, focus, and enjoy. Thank you.
Finding the LCM using prime factorization. If we have to find the LCM of 12 and 32, we know we can list some multiples and find the smallest value common to both numbers. So multiples of 12, 12, 24, 36, 48, 60, 72, 84, 96, 108. And for 32, 32, 64 and 96. The LCM is 96. Now I'm going to use these same numbers to show you how to find the LCM using prime factorization. And the great thing about this method is it works for any number of any size. First, we do the prime factorization of each of the numbers. Primes in red and composite numbers in blue. 12 is from 2 times 6. 6 is from 2 times 3. Circle the primes. 32. 4 times 8 is 32. 4 is from 2 times 2. 8 is from 2 times 4 and 4 is from 2 times 2. Circle the primes. Next, we make a quick table of the prime factors. Using columns, we match the like factors. Leave a space where there's no match. 32 has the prime factor 2 5 times. Write them in. 12 has the prime factor 2 twice. I leave spaces and then put its remaining prime factor 3. I put a line under the prime factors to help my thinking. Finally, we find the prime factors of the LCM. We use one factor from every column, and if there's a vertical pair, we only take one of those factors. The LCM of these numbers is the product of these factors. 2 times 2 times 2 times 2 times 2 times 3. Work it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 times 3, well, 3 times 2 is 6, and 3 times 3 is 9, so the LCM of 12 and 32 is 96. And we know this is right because we already found the LCM using the multiple listing method. Now we know the method works, let's try a slightly more tricky pair. 28 and 35. First, find the prime factors of each number. 28 is from 4 times 7. 4 is from 2 times 2. Circle the primes. 35 is from 5 times 7, both prime. Next, we do the prime factors table. Match factors vertically, leave a space if there's no match. 28 is 2 times 2 times 7. 35 is 5 times 7. Now we get the prime factors of the LCM. 2 times 2 times 5 times 7. Finally, work out the value of the LCM. 2 times 2 is 4, times 5 is 20, times 7 is 140. You can see when you are given even bigger numbers, using the prime factorization method is going to be very helpful. Now here's a challenge for you. Using the method I just showed you, find the LCM of 15, 32 and 66. You can do it. When you've done, the more practice you do, the stronger your math muscles become. Comparing and ordering fractions for beginners. We can compare fractions and put them in order using fraction strips. Here's 3/4 and 1/4. And here's an illustration of those fractions using fraction strips. You can see straight away that 3/4 is the greatest fraction. Next, we write about that using the greater than or less than signs. We're going to show the fractions from least to greatest, and that's smallest first. Now the fractions are in the right order, but which sign do we use between them? Not sure which sign to use? Don't worry, here's the easiest way to put in the right sign. We can think of these signs as having 3 dots, 2 here and 1 here. 2 dots always go beside the greater number in the pair, and 1 dot beside the smaller number. 2 is greater than 1, and here 1 is less than 2. We understand the sign from left to right, like reading a word on a page. Going back to our fraction pair, I put the 2 dots beside the greatest fraction and 1 dot beside the smallest fraction. Now, join the dots. 1/4 is less than 3/4. We used the less than sign without any confusion with this easy thinking. When fractions have the same denominator, we just line them up in size order using the numerators. Easy. We don't even need to use fraction strips. We'll have one last example, then it's your turn. We're going to put this group of 4 fractions in order from greatest to least. We start big and go small. This time, I'm not going to use fraction strips. The denominators are all the same, so the numerator tells us the greatest fraction. And 7/8 is the greatest fraction because it has the largest numerator. The next one down from this is 5/8, then 3/8, and the smallest is 2/8. Now they are arranged in descending order. We have to use the sign that shows that relationship. Between the first 2 fractions, put 2 dots for the bigger fraction and 1 dot for the smaller fraction. Join the dots, and there's our sign. Greater than. 7/8 is greater than 5/8. And again, between 5/8 and 3/8. 2 dots by the greater fraction, 1 by the smaller fraction. 5/8 is greater than 3/8. And the last one, put in the dots, and there's our sign. So we have written 7/8 is greater than 5/8, which is greater than 3/8, which is greater than 2/8. You can do this too. It just takes a bit of practice. Speaking of which, it's practice time now. And next time, we'll see how fraction strips can be very useful when you're comparing fractions with different denominators.